66 million years ago, an asteroid strike ended the reign of the dinosaurs. In the aftermath, the apex predator position, the absolute top of the global food chain, lay empty. The removal of the dinosaurs left millions of square miles of prey and territory unguarded. This ecological opening exerted a massive evolutionary pressure on any survivor capable of scaling up to fill the gap. A lineage of cold-blooded reptiles seized this opportunity, reaching a scale that defied every modern assumption about the limits of vertebrate anatomy. The catastrophic death of the dinosaurs transformed the tropics into a lawless, overheated breeding ground, the perfect environment for a biological anomaly. We only know the details of this era because of a discovery in an unlikely place. This is the Cerrejón coal mine in northern Colombia, one of the largest open-pit excavation sites on Earth. Deep inside these pits, excavators uncovered fossilized vertebrae. When scientists reconstructed the spine, they found it belonged to a snake measuring 42 feet long and weighing over 2,500 pounds. Paleontologists named this superpredator Titanoboa. Maintaining a body of this magnitude requires a specific, extreme set of environmental conditions. These remains provide definitive evidence for a version of Earth operating under physical rules physiologically lethal to almost everything alive today. To understand those rules, we have to look at the maximum limits of biology today. In the hottest, most humid jungles currently on the planet, the largest modern constrictors, like the green anaconda, top out at around 20 feet long. This correlation exists because cold-blooded reptiles cannot generate internal body heat. Their maximum size is strictly limited by ambient temperature. To reach 42 feet, the Paleocene Earth had to be a sweltering, ice-free greenhouse world, with average equatorial temperatures near 90 degrees Fahrenheit. Titanoboa functions as a living thermometer. Its existence is the physical proof that the Paleocene was a lethal hothouse that forced reptile growth into nightmare proportions. While modern constrictors target soft-tissue mammals and birds, the Paleocene swamps were dominated by massive, heavily armored prey, including giant prehistoric turtles and early crocodilians. Titanoboa evolved into a specialized crocodile killer, built with the sheer constrictive force required to crush the thickest natural armor in the river. Its skull features specialized architecture, rows of densely crowded needle-like teeth angled backward like fishhooks. These were designed specifically to pierce wet, thick scales, rather than grip fur. A 1-ton snake cannot hunt in the tree canopy. Gravity forced Titanoboa into the water, where it became the ultimate aquatic ambush predator. It could lie perfectly still on the riverbed for up to an hour, holding its breath, waiting for armored prey to swim within striking range. This wasn't a scaled-up version of a modern boa. This was a highly specialized biological weapon, reverse-engineered by its environment to dominate the most protected animals on the planet. For over 1 million years, Titanoboa remained the undisputed king of the Paleocene. Eventually, however, a shift in the global environment turned its greatest strength into a fatal weakness. Global temperatures began a gradual but catastrophic decline. As the planet cooled, Titanoboa's once lush habitat simply vanished. A cold-blooded engine of that size requires immense external heat to function. As the air chilled, Titanoboa could no longer extract enough energy to metabolize its food or move its massive muscle mass. This climate-induced starvation ended the reign of the giant reptiles, clearing the path for smaller, warm-blooded mammals to claim the empty throne. Titanoboa stands as a fossilized reminder that evolution is at the mercy of the planet. It proves that biology is entirely dependent on climate, and that shifts in global temperature can breed terrifying anomalies.